Thank you, Andreas. And no worries about the X-rated candid questions. Back in 2014, I was at one of the very early Bitcoin conferences in Toronto, and of course the only central banker there. So that was a bit of a baptism of fire, given some, let's say, the maybe a bit of a cultural disconnect, but it was actually fun. So first of all, Andres, thank you, and thank you so much to the organizers of this series for inviting me. It really is an honor, and I must say I feel a little intimidated, given that that your first speaker in the series this year was Professor Duffy, who of course is a deep thinker in this area around CBDC in general and interoperability and so on. I think my presentation will be probably more at the practitioner end of the spectrum, definitely not at the academic end of the spectrum. But nevertheless, I hope there's something here of value for the audience. So I want to really speak about three different areas, which are all connected, of course, right, to blockchain. So the first is our work with Project Jasper, as Andreas mentioned, over the last few years. And then I'll speak a little bit more about perhaps where most of actually our attention is now, on the possibility of a retail CBDC. Jasper was all about interbank payments and financial market infrastructures. And then lastly, I'll present some recent thinking around this, the notion of trust, but kind of early days, and with the hope that perhaps as a community we can progress this work in the thinking. Okay, so let me first start, well, actually with the disclaimer, because it is after 5 p.m. I'm on my own time, and these are my views. These are not the views of the necessarily the views of the Bank of Canada, although of course I am presenting the work that the Bank of Canada has undertaken. So with that, we'll start with Project Jasper. And as I mentioned, as Andreas mentioned, this was actually a series of projects, sort of four and a half. I'll explain why the half in a moment. Really looking at the potential impacts of blockchain, and I use blockchain and DLT, distributed ledger technology, interchangeably here for our purposes. Really looking at what they can bring to wholesale markets, wholesale interbank payments. So, okay, so this goes back actually some time. In fact, we started back in 2016. I think this was about 2 years after the first release of Ethereum as a more generalized platform on which you can build blockchain-based applications. Before that, we had these Bitcoin onwards, we had these really kind of custom-made for a particular purpose rather than generalized platform blockchains. So this was the motivating question, right? What can DLT bring to financial markets that improves over more traditional centralized systems? So I'll go through this in more detail in upcoming slides. But we start in as a summary in 2016. Very simple Ethereum-based stack. This is not running on public Ethereum. This is taking the Ethereum source code and really standing up a permissioned network. I should also say that in none of these projects do we have real transactions, right? So there's all proofs of concept. No real money was harmed in the making of any of these experiments, right? So these are all proofs of concept. So the first one, 2016, fairly straightforward, taking Ethereum stack and allowed interchange of payments between market participants. In the second phase, we built on that, but actually changed platform, right? So we changed from Ethereum to Corda for reasons I'll go a little bit into, and actually changed the functionality, right? So we did something that is pretty much necessary in most interbank payment systems. That is to add a liquidity savings mechanism, a netting function, and it's interesting to see what challenges that raises. Third phase, we did a DVP, delivery versus payment. So on the one side, we have equities. On the other side, we have a central bank liability, both on ledger the experiment was about seeing what efficiencies can be brought about if we settle these the settlement of these transactions, the equity cash transactions on ledger. And finally, there's something in the middle actually. Before phase 4, we actually undertook some work with the Bank of England, the Monetary Authority of Singapore, which is the Singapore Central Bank, in examining really what the issues are with cross-border payments and putting forward a few ideas on how matters could be improved. And one of those ideas was the use of technologies, including blockchain. And then in phase 4, we worked with the Monetary Authority of Singapore to really create, which I'll go into later, a cross-border, cross-currency, cross-platform payments mechanism. Okay, so let's start with really, so Jasper 1 and 2 functionally have a lot in common, as I mentioned, right? They're really just about the transfer of payment from one market participant to another. So they have a very similar life cycle, which I'll explain with one difference. So ultimately, what we're really trying to do is tokenize a liability of the central bank and put it on a ledger, right? So in the wallet of some market participant, which they can then transfer to another market participant, right? So this starts with a financial institution that wants some of this, let's just call it a CBDC, but before we used to call it a DDR, a digital depository receipt. They give cash collateral to the central bank. The central bank makes sure that it's good. In this case, it's just cash collateral, so there's a one-to-one relationship with the DDR that's issued to a wallet on the blockchain. Okay, so each of these market participants has a wallet, and in their wallet they have this DDR against the collateral they posted to the central bank. Once they have that, that's it. They're then free on the blockchain without the involvement of the central bank to exchange value from one institution to another, mediated by the Ethereum blockchain. Okay, in phase 1, it's the Ethereum blockchain, and I'll explain in a second why we call this atomic. But at the end of the day, or the end of some period, we can go back the other way. The institution can take its DDR in its wallet, send that back to the central bank, and the central bank will credit its cash account with that collateral. Now, in phase 1, we had a very simple atomic transaction, right? So this would be, for those of you who know this industry, real-time gross settlement. That is, that there's no netting or anything like that, right? You make a payment for which you are fully collateralized to another party. In phase 2, so actually before that, let me just explain. When you and I, make payments to a coffee shop and so on, we turn up with exactly the money that needs to be transferred, and we pay the whole amount. But when you think about a large number of transactions happening through the day between a participants in a particular market, to actually cover the maximum outstanding amount you might have during the day could involve having to post a lot of collateral, especially if you're talking about tens of millions or even hundreds of millions of dollars. That's a lot of collateral. A more collateral efficient way of doing this is to allow netting. In other words, during the day, you can have a short position, right? So effectively, you're short dollars, you may be long dollars, but of course the net value across the whole system is zero. So in phase 2, we added this using Corda, this netting function, this liquidity savings mechanism as a netting function. And this is quite interesting to examine. I won't, we don't have enough time, but I won't go into the details of exactly how each phase was set up. I'll just focus on what I think are the more interesting areas when we think about blockchain and CBDC. So in the case of phase 2, here's sort of highlighting what happens in a centralized system before we talk about blockchain, right? When we have a liquidity savings mechanism. So these market participants, these FIs, they're making their transactions through the day. They're not settling, right? They're just effectively clearing. They're on a queue. So these are pending transactions. And at the end of the day, now in the case of Canada, you could be end of some period, but in the case of Canada, at the end of the day, the central bank can look at this queue of transactions and net them out, right? So we have 20 market participants. Some are long, some are short. We run this pretty simple netting function, and then the central bank knows that in order to settle on its books, right? So remember, the central bank is the one that's holding these accounts for the market participants. It can simply move a value from one account to another. So this is really no different to when you and I have bank accounts. We have maybe different bank accounts. The bank can simply move value from one to another on our behalf. Now, in this case, the central bank has this privileged access because it has the books to be able to do that, right? So there's no issue there about access to these funds. So the central bank can perform this netting function without any issue. Now, in the case of distributed ledgers or blockchain, we have this problem, right? So we can do the first two things, have these functions proceeding through the day, and then we can net these short and long positions. However, by design, because we've tokenized these values, these DDRs exist in the wallets of the market participants, right? So it's much more like a cash system, right, where the central bank is not able to effectively dip into a wallet in order to settle these across these accounts or across these wallets in this case. So it doesn't have this privilege. You could think of mechanisms where it could. I mean, the crudest would be that the central bank also holds the private keys to these wallets, and of course, this completely violates the idea around of blockchain and the entities having custody over their own assets. So that's not a very good way to do things. So we had to perform something of a workaround, which was novel, but it does speak to something about blockchain. But let me just explain the mechanism first of all. So imagine what's happening through the day. As you saw in the previous diagram, the transactions are being made. They just end up on this queue. Okay, they're pending, and at some point in time, end of the day, in the case of Canada, you freeze the queue. And because you're not able to just net there and then, the mechanism here, the idea here, is that the settlement agent, meaning the bank who's performing this netting function, asks each institution to send the central bank enough DDR to cover any short position that they might have. Okay, so if there are 20 institutions, each of them, if they have a short position, will send whatever they think is required to net the position. So what that means is that the central bank is holding that value, so it can then it's receiving this DDR. It runs this algorithm, and then it can effectively net and send any change, if you like, back to the institutions, okay, each of the institutions. Now, the problem of this, of course, is that we've introduced the central bank as a trusted actor here, right, as a trusted settlement agent, when a lot of the, what we want to do with blockchain is to actually remove that. In this case, we would argue that that's actually okay, because you're trusting the central bank anyway, right? These market participants are holding a liability of the central bank. So inherently, you are trusting the central bank as a settlement agent anyway. So going this step further doesn't seem like that big a deal. So let me just go back one. So now there's one problem with this. I think that the biggest problem is that when we think about this as a particular function, right? This netting function, it's inherently centralized. right? So in the case of blockchain and so on, we think about decentralization, but nothing is inherently centralized function. And as demonstrated here, what we're essentially doing is we have defined a workaround of some kind. We have to sort of bend the technology to make it work. And there is an argument when you think about systems architecture that whenever you have to do that, whenever you have to kind of bend the intention of a system against what is its kind of natural state, you tend to end up in trouble. Okay, but anyway, there's a thought there. So I'll do maybe a couple of conclusions in phase 1 and 2, right? As a summary, we have there are a set of principles for financial market infrastructures, really pulled together by a group of central banks under the Bank of International Settlements. These are just 4. So on the left-hand column, you see these 4 principles. I think there are actually about 20 something of them, but these are the ones that are relevant to the thinking about interbank payments. And I'll just highlight a couple of things. So in the second column there is LBTS. So LBTS is Canada's large value transfer system. So this is the current centralized operating system that's actually run by Payments Canada, not by the Bank of Canada. Oh, so let me first focus on something important actually. Both of these projects were a collaboration with Payments Canada, ourselves, the large financial institutions, the large banks in Canada. Phase 2 involved R3 as a technology provider, and also Accenture. Okay, so this was a collaboration. This is not something where we did this ourselves by any means. So here's a couple of things that are interesting. Okay, so of course, as you'd expect, in the case of the centralized system, all these principles are satisfied, right? It's designed so to make sure they are. In the case of phase 1, using Ethereum, there are 2 particular challenges. And I think the first one is probably the most important, this idea of this problem of probabilistic finality. I think many of you will know that the Ethereum has this consensus mechanism called proof of work. And the nature of proof of work is that what looks like a state that signifies settlement of a transaction could actually change, right, over time, just because of the way the mechanism works. So there's a possibility that something that looks a transaction that looks like it's bound, and therefore the underlying transaction is settled, then changes, right? A new chain is formed. Now, this may not be a big problem for very small transactions, right? The receiver may be willing to take a risk. If you're buying beer or something, right, may not be that big a deal. If you buy something more expensive, a car or something, then the idea is, well, you should maybe wait for at least 6 new blocks on the chain, and then you can be really much more confident that this is final. If you're sending millions of dollars, maybe tens of millions, that's a real problem. Right. So anyway, problem number 1, this probabilistic finality. The second one, actually not so important in the case of Canada. With Ethereum, we're limited to about 12 transactions per second, which is just about enough, in fact, for the LBTS. But we know there's more progress on this front. What's also interesting on a very positive side is that third row, this operational resilience. Ethereum in particular has redundancy built in, right? There's replication across all these different nodes. If any particular node or even some quite high percentage of nodes fail, the system can carry on, right? So it has this very high resilience that's built right in. In the case of Corda is quite a different sort of blockchain system. State is not completely replicated across all nodes. That's by design. Partly around confidentiality, but also efficiency. 2 nodes only share the state that's pertinent to the institutions running those 2 nodes. In other words, every node doesn't have an entire view of the system. Now, what that means is that unlike Ethereum, you can't rely on every other node being the same, right? Which means you do have to, as in traditional centralized systems, you do have to stand up high availability and disaster recovery and so on. So what that means is there is expense there. Now what we have then is a situation where perhaps there are 20 market participants and they all run nodes. That means they all have to stand up a highly available environment. So one argument is that in fact the overall cost of the system, and I do mean the technical system, I don't mean, there may be other savings you can make, but the overall cost of the technical system is actually higher than the centralized system because everyone has to run these nodes. Some more general sort of thoughts and maybe not completely firm conclusions we came to is that if you're thinking about using DLT solely for the purpose of interbank payments, it probably doesn't make sense, right? There probably isn't really any savings to be made there, and that if there are any savings to be made by using blockchain and DLT, it's more likely to be something that happens at a larger scale. In other words, at an ecosystem level, right? This really isn't a technology that makes sense if you think about a particular application, right? You've got to think about a whole ecosystem. And that's actually a hypothesis. That's not really a conclusion, right? This sort of outstanding hypothesis. And the final one I mentioned there, which is that there are functions. So LSM is a liquidity savings mechanisms is a good example, which is that it's inherently centralized, and doing this in a decentralized system is actually really hard and adds a lot of complexity to it. Okay. In Jasper 3, we moved from purely interbank payments. You're thinking about settling against an asset on chain. Okay, so the idea here, so we worked here with TMX, Toronto Stock Exchange, and the banks, as I mentioned before, to put both DDR, so the central bank liability, its tokens on ledger, and equities on ledger, both on a single ledger. Okay, in this case, Coda again. So the idea here is that you tokenize both of these. The tokenization works exactly the same way as before in Jasper 1 and 2 on the cash side, and in a very, very similar way for equities, right? So there are assets pledged from the depository system against a tokenized form of the equity on ledger. Now, so in this experiment, the settlement happens actually in a batch process. At the end of the day, there's netting, and long story short, it does work, right? It absolutely works, as in Jasper 1 and Jasper 2. But I think one of the interesting things here that we hadn't, I guess, a small insight, but possibly quite important in the longer run, is that you can think of this as a linkage between two centralized systems which are quite old, CDS and LBTS. And what the ledger brings is, if you like, a sort of a common space in which interactions can happen between those two systems without actually having to create those linkages explicitly, right? So, in a way, it's a sort of if we're living in a world where not everything is on ledger, it provides us opportunity to perhaps create interactions between centralized systems in this common space, and avoids a sort of end-to-end complexity. So that's kind of interesting, I think, as a sort of a transition, if there is to be this sort of a generalized move to create using blockchain ledgers in the financial system as a whole. So perhaps a bit of a repeat of what I'd said for Jasper 1 and 2. Again, to us, it seemed as if even though we've added a new asset, is too small. It still feels like that there won't be substantial cost savings to be had here until perhaps we have something at a larger scale. Well, I'll mention one problem here. You know, in the industry, there have been lots and lots of experiments, lots of proofs of concept, and so on, and each of them, you know, they work, but I don't think anyone's shown, and of course, people may disagree, any sort of killer app yet, and that doesn't surprise me, right? Because as I said before, this really isn't an application level technology. But there's a problem here, right? You know, all these proofs of concept go a certain way, and they give us a little glimpse into the future. The problem is if we have this hypothesis that is, you know, that the value of blockchain is really about scale, right? When you do things, when you have a lot of instruments, when you have a lot of participants, maybe you have federations of chains interoperating and so on. Maybe it's only then that you really start seeing the value of this. But of course, that doesn't sound like a proof of concept, right? I mean, that doesn't, you know, that's large scale. So I think we have this gap, which is potentially a real problem in actually furthering experiments, understanding of blockchain. Perhaps it needs a leap of faith. You know, I'm not quite sure, but I think there's a real problem here in where do we go next to prove that this technology makes sense. Okay, so let's move on to, in fact, we don't call it Jasper 4, we call it Jasper Ubin. So the Monetary Authority of Singapore, MAS, has actually done work in parallel, really along very similar timelines to the Canadian experiments with the Canadian participants in the Jasper series of projects, starting back around the same time in 2016. Not exactly the same, very interesting because there's some interesting differences between the work the MAS has done with its participants in Singapore. But nevertheless, from this paper I mentioned that we worked on with Bank of England and the MAS, there was this idea around, well, what can blockchain bring to cross-border payments? Can it bring any new efficiencies for what is really quite an antiquated, I was just about to say system, right? But that's wrong. I mean, one of the problems in a way, ignoring something like CLS, is that there isn't a system as such, meaning a technical system that really creates efficiencies in cross-border payments. There are rather these arrangements of correspondent banks, and which lead to various problems, inefficiencies, issues with, you know, transparency of information, high costs, it's slow, you know, a whole host of problems. So one of the thoughts here was, well, what can blockchain bring to this problem? So let me explain what's going on here, the setup here. Imagine these are two countries, say Singapore and Canada. The boxes on the far ends of the slide are really the RTGS systems, the payment systems, centralized payment systems in each country. Now, the use case here is that Bank A, let's say Singapore, wants to send a payment on behalf of a client to Bank B in Canada. Okay, so the setup here is that Bank A, starting with the, I don't know if you can see this, because you probably can't. You see the number 1 there on the left, sends cash collateral to the MAS, and then in number 2, the MAS puts on ledger for Bank A the corresponding amount of CBDC wholesale, that W means wholesale CBDC, into the wallet of Bank A. Okay, so those two inner large boxes essentially represent 2 ledgers. Okay, so 2 completely independent ledgers. And in fact, in the case of Jasper Ubin, we purposely chose 2 very dissimilar platforms. In the case of Singapore, they use Quorum. So Quorum is a Ethereum derivative. And in the case of Canada, we used Corda. Corda again. Really very, very different platforms. And we did this on purpose because we wanted to see, could we take two quite dissimilar platforms, but nevertheless enable this cross-border transaction, cross-platform, cross-currency transaction to happen. Now, as I said before, that there isn't a system as such in CLS, in cross-border payments. What actually happens is that there are these independent ledgers in different countries that have to be updated simultaneously, right? So you send money from country A to country B. What's actually happening is that there are ledgers in institutions in both countries that have to be updated simultaneously, right? That's actually what happens underneath the covers. So in the case of this transfer between Bank A and Bank B, what happens is that there's actually two ways to do this. Let's assume that Bank B actually has a presence in both countries, right? There's let's say a TD Bank in Singapore as a separate legal entity, and a TD Bank, of course, here in Canada. If there isn't, what you see in the green there is another option, which is an intermediary of some kind, right? So this would be a bank that has, a Bank C, has a presence in both countries that can act on behalf of Bank B to make the transaction. Okay. So what would happen is in step 3.1 there. So Bank A already has Singapore dollars in its wallet. It sends those to Bank C, and then and just after that, Bank C on the Canada side, what you see there in 3I, would send corresponding amount of Canadian dollars to Bank B in Canada. Okay, so that's essentially the transaction made. And then at the end of the day, or whenever it wants, Bank B can go back to the central bank and effectively cash in its wholesale CBDC into its reserve account. Now, the key problem here is that what happens in steps 3.1, they have to happen simultaneously, or they have to happen atomically. So either all or nothing, right? Otherwise, of course, what's happened is that the ledger has been updated on one side, but not on the other. Side. Okay. So the question is, what can DOT bring to this problem? Okay, I'm just going to look at the clock. Actually, running a little slow. I won't go through this in excruciating detail, okay, because it'll take quite some time. But the mechanism we chose to try and guarantee that all or nothing, that atomicity between the two ledgers, was this idea of a hash time lock contract. Not something we invented. This was a technique that's already existing. But I'll give you the sort of headline, the sort of broad strokes of this for folks who haven't seen it. So the idea here is to have to explain the diagram. We have Bank A on the left there, trying to send something to Bank B on the very right, from the very left to the very right here. In this case, in the middle, we've assumed that there is this Bank C, this FI that has presence in both countries. Now, what you see here in the DLT Singapore dollars and DLT Canadian dollars are the two ledgers. So what happens? The setup is that the Bank A effectively sends money to a smart contract on the Singapore ledger and effectively locks it up. So there's an escrow function there. Okay. Now this is not actually held by an institution. This is actually held on the blockchain, right? The blockchain holds it in escrow using a smart contract. Similarly, the same thing happens on the Canadian side, where the Canadian dollar leg of the transaction is held in escrow in the Corda blockchain. When you're ready to transfer, the setup is that there's a message sent to the receiver that both of these escrows are ready, the receiver will send a message to the local blockchain requesting it to release the escrow. So it'll present a shared secret. The blockchain on the Canadian side will be satisfied that the shared secret is valid, and it will release the funds. The receiver on the Canadian side will send a message to the correspondent bank, C, which in turn will send a message to its correspondent in Singapore that will release the funds on the Singapore side. Okay, now that was rather rushed, but let me mention one thing here. That's another finding, if you like, which is that there's a problem with using Corda here. Just the nature of the platform at that time, back in 2018, in that it wouldn't really allow it wouldn't really allow an escrow function to work well. It wouldn't allow timeouts, which is what you need to make sure that, if messages don't get sent, the whole thing times out and the funds are returned. So again, we had to make a compromise. And the compromise was essentially that the central bank in Canada becomes a trusted party, and it is the escrow, right? So it performs the escrow function rather than the DLT doing it itself. Again, the reasoning was that, well, the central bank is trusted in Canada anyway, so that works because it's trusted by the participants in Canada. It doesn't have to be trusted across the board. In other words, the central bank doesn't have to be trusted by the bank in Singapore. So the long and short of this is that this is an interesting application of DLT, because it means we haven't had to create a trusted party, a trusted third party that's commonly trusted by all, right? So that's something that's net new, and I'll talk a little bit more about that when we talk more generally about DLT. Okay, if there's any questions, we can go back to this later, because I know I went through it pretty quickly. There's actually quite a bit more to cover. So yeah, a couple of things to mention here. The first one I already mentioned, right? This is difficult to create an escrow function in a peer-to-peer network like Corda. HDLC isn't actually perfect. It can fail. I showed this diagram here. Between those green boxes there and the blue boxes on the right, that messaging between the two, in fact, is not on the blockchain, right? So there's a need to pass a secret and messages between the two, and that has to be very reliable, right? So that doesn't use the blockchain. It has to be very reliable. So if that fails, then potentially we do have a problem. So we need to build in redundancy and so on. And even redundancy may not be enough. So we need mechanisms for dispute resolution as we have now. Let's see. Yeah, let me jump to that fourth bullet point there. This whole mechanism works at a kind of application level. In other words, it's kind of coded into the smart contract. And if you think about how think about atomicity as a primitive, as you have in databases and so on, right? That's kind of the wrong level for it, right? You can argue that that's something that should be really built deeper into the protocol, in the underlying platforms themselves, rather than at this kind of application level. In other words, people who are developing applications really shouldn't have to bother with this kind of stuff. So although it works, I think there's a strong argument that this is something that should really be built at a lower level in the protocol. Okay, so kind of a change of subject, actually. So what I showed there was is all about wholesale interbank payments and financial market infrastructure for wholesale markets. We've actually done quite a lot of work on retail central bank digital currency. And what I mean by that is literally, the central bank digital currency that you and I can hold. In fact, when I first started work on this was actually back in 2014 at Bank of Canada. So we did it for quite a few years, and the work started before I did. Now it's very part-time, in those early days, few researchers on the economic side, myself. But since then, it's ramped up and it's become more mature. And there's quite a lot of attention being paid to this in the bank. But first, let me just give you a little bit of the flavor of the landscape more recently, because things have changed actually quite a lot in, I would say, the last year or so. So I mentioned first, of course, because I have to, right, that a lot of our research work over the years I mentioned culminated in this paper we published in February of this year. And it's really a combination of our position on how we think about central bank digital currencies. And I'll talk a little bit more about that in a second. But there's a lot of other work going on. So the Riksbank, the Swedish central bank, has done lots of great work in the e-krona project, which you can, of course, read more about. Andreas mentioned the European Central Bank, the ECB publishing a report just a month and a half ago, something like that, on their thinking on a digital euro, a CBDC, in fact. And similarly, the Fed has joined work, the Bank of England, and actually many other central banks. And I believe the BIS has said that a majority of central banks are now actively researching CBDC. Okay, so it's really grown dramatically over the last year or so. And there's a group of central banks, 7 central banks, who have got together and have published a report again, I think about 2 months ago now, on some really broad foundational ideas around CBDC. And I would, for anyone interested, I would highly recommend looking at these reports. I guess more practically, I mean, that's research work. A couple of things on the ground. The People's Bank of China have undertaken this experiment. It launched a pilot in 4 cities, which well, we'll have to see how it goes. It's early days yet, I think, to know exactly where it's going. But that'll be interesting because, of course, the PBOC is a major central bank and a huge market, so it'll be interesting to understand. That said, I should say that across many jurisdictions, the drivers tend to be really quite different. So the market in China may not be particularly relevant to, say, the market in Canada, but no doubt there'll be some very interesting learnings from the pilot. And we have an actual release, not just beyond a pilot of a CBDC. So the Bahamas, I think, was it just a month ago, released their sand dollar, which is available to all in the Bahamas. So we actually have a system that's live beyond pilot. Okay, let me just speak a little bit about how we think about this. We don't think about CBDC in isolation. If we stand back, we try and think about the whole payments landscape, as you might expect. So in Canada, there is this major effort centered around Payments Canada, who operates a system to actually modernize the platforms that have been around for quite some time. The Bank of Canada is, of course, fully supportive of this. We have, oversight responsibility for these systems, and if this serves the Canadian economy well, of course, the bank is very supportive of this work, and been very involved in it. Secondly, cash has some really wonderful properties, and is actually important for many communities, many people, in Canada. So we're fully supportive of making sure that as long as Canadians want to use banknotes, they'll be available. And to be honest with you, the more as time I spend thinking about CBDC, the more I'm just in awe of really how amazing banknotes are, right? Just how well they work. It's quite remarkable. We just forget about them on a daily basis. But when we step back to actually think about the problem they solve, it's really quite extraordinary, right? Anyway, and the final leg of this is the idea of a central bank digital currency. Now, the Bank of Canada has thought about this as a contingency plan to now. Okay, so I'll talk a little bit more about that in a second. In other words, we don't think that the conditions to issue a central bank digital currency exist at the moment. I think Canadians are really well served by other means of payment right now. But in the future, though, it's quite possible that it would make sense to issue a CBDC. So here are the sort of the two kind of broad conditions that may make it reasonable to issue a CBDC. So the first is that banknotes decline. For example, merchants stop accepting them, and they decline to a point where they're really not an option for transactions in Canada. So that means that people essentially don't have access to a risk-free instrument by which to make payments. They don't have a public option anymore. And the other one, and not exclusively, is that the Canadian dollar starts becoming displaced by something else, right? Perhaps another private digital currency. Could be another sovereign currency of some kind, perhaps even through a foreign CBDC. That's a problem because it makes monetary policy and lender of last resort functions quite difficult if a large part of the Canadian economy is not using the Canadian dollar. Okay. Now, what exactly? It doesn't mean that should either of these conditions come to pass, then automatically the central bank will issue a digital currency. It's of course far more complex than that. There's a generalized discussion that has to happen, a public discussion, a political discussion that would have to happen before a central bank digital currency is introduced. So it's not as if there's some level that automatically triggers the introduction of the CBDC. Far more complex than that. So just think about a little bit about what exactly does this look like? What does a CBDC look like? In many ways, it's actually quite different from other payment mechanisms, and I think this is important to understand because in some ways you might many people might think, well, this is just another type of payment system. It's just like commercial bank money, for example, and that's it, right? You just stand up you just stand up a system as any bank would, and that's it. But in fact, that's not quite the case, because for a central bank, there are a set of public policy objectives that are different from commercial objectives. So, for example, as with banknotes, a CBDC, if it's introduced, should be universally accessible, right, to everyone. So, regardless of your circumstances, if you're living in perhaps a region and it's quite surprising, that doesn't have perhaps reliable network connections, you should be able to use it. If you have, well, I'll talk a bit more about what the challenges are, but nevertheless, universally accessible. Privacy. So banknotes, of course, are very, very private. In the case of a CBDC, we're not thinking of privacy to the level of anonymity. We're thinking of privacy with compliance. Nevertheless, we think privacy in payments is a public good and actually valued by Canadians. And we'd like to provide privacy to the extent possible, but staying, of course, compliant with regulations. Resilience. Banknotes are incredibly resilient. And similarly, we would expect a CBDC system to be extremely, extremely resilient. Needless to say, it needs to be very secure and very safe. That's kind of the bottom line. Without security, you would have no confidence in the system. Beyond the features of the CBDC itself, introducing it could have some valuable properties in providing competition and therefore driving innovation and efficiencies in the payments market, which could be quite beneficial to Canadians and firms and so on. And that final one, of course, relates to the point we made in the previous slide, where we want to try and make sure that the Canadian dollar remains the primary choice of the unit of account for transactions in Canada, and CBDC could support that. So this is challenging, in fact, and some of these things are very challenging, right? So we can imagine that a primary means of using a CBDC could be a smartphone, and that's what we would expect, given that that's how the majority of Canadians actually do have. They do have that as a platform. But we needed to work for people who don't have smartphones, and as I mentioned, for people who live in remote communities, for people who have certain impairments, sensory, cognitive, motor impairments. Right? We have to try as much as we can to make it work for all Canadians as a policy objective. Privacy is very difficult. We have this dichotomy of privacy and compliance, and we need to try and achieve both. So compliance is something of a given, of course. Just as with anyone else, we are expected to comply with the regulations and laws of the land. But within that context, we want to see how much privacy we can provide from really as many participants in the ecosystem, including the central bank, as possible. I mentioned resilience. If we go really to the max and think about offering resilience when the power goes out, when networks are down, and so on, just how do we do it? So we have some ideas around this kind of peer-to-peer transfers and so on. Security, I mentioned, needed to say, we have to provide security at the highest level. Finally, the intermediation point. This is supposing a business model where, in fact, the central bank doesn't do everything. It works with the private sector, which is not an unreasonable supposition, I think, where the private sector provides the end user experience. But in that case, what is that relationship between the public sector and the private sector? And how do we make sure that the integrity of the system overall, when the central bank can't control the system overall, is maintained? Okay, so that's also quite a tough challenge. All right, so back to DOT, and thinking about this in the context of retail. Not much to say about universal access. That's largely about the endpoint, the endpoint design. However, of course, the DOTs are network dependent. So what do we do in the case of communities that don't have reliable network coverage? With privacy, it's a bit of a tricky one, because much of the work going on in, for example, zero knowledge proofs seems to be done in the context of DLT. But of course, zero knowledge proofs are not intimately naturally bound to DLT. It just so happens that that's where a lot of the work is going on. And one thing we do find is that when we start using these techniques like zero knowledge proofs and so on, it adds to the scaling issues of DLT, which already exist. Resilience, I've mentioned before in the context of Jasper 1, with certain types of blockchain systems, resilience is kind of just part of the fabric of what this does. There is an argument that we know how to build highly resilient systems anyway, but nevertheless, I shouldn't take away from the fact that Bitcoin has been going for 10, 11 years now, pretty much without a hitch, maybe a few hitches in the early days, and showed remarkable resilience. And the last one I mentioned, intermediation. integrity. So how do we know that some intermediary, perhaps a bank, a fintech, and so on, is really behaving, right? That there's nothing going on where they're creating what looks like CBDC, but really isn't, since the central bank is the only one that can create central bank digital currency. Perhaps DOT can help here in making sure, because if we have a unified system using blockchain, perhaps it's quite straightforward to figure out how much money there is in the entire system. Still is a last mile problem. We don't know what's happening with at the jump between the blockchain and the wallet, but nevertheless it goes somewhere. And there is complexity, right? The governance becomes quite complex with not necessarily DLT, but just any kind of decentralized decentralized system. And there's a question of which is cheaper. Should we just police these MSPs, drop in audits and so on, or is it actually cheaper to do it through a systems means? A couple of other things, people mention immutability, so that enhances trust in the central bank, because you can check on the central bank and so on. But I think an argument I would make is that, well, if you're trusting the instrument anyway, aren't you inherently trusting the central bank to be well behaved anyway? And there this again, programmability, something that arguably doesn't need blockchain. Nevertheless, almost all the work going on in this area seems to be around blockchain. So that's quite interesting, right? This ability to provide, as I mentioned before in Jasper Ubin, this idea of computationally binding commitments. And it's quite interesting to think about whether there's a new set of capabilities and functions that can be created as a consequence of that. I think a lot of the decentralized finance ideas, of course, are based on this. So, here, I mean, in the escrow function, I mentioned that, well, a trusted entity could actually provide an escrow function. So one observation I would make, maybe I would contend, is that it seems to me that underlying many of these benefits that are touted with distributed ledgers are really about trust, right? This idea that the fundamental benefit of blockchain is about either the need or the ability to remove these trusted entities and perhaps provide efficiencies by getting rid of intermediaries, or maybe perhaps even more interestingly, being able to apply blockchain where there are no trusted intermediaries, no trusted entities in the first instance. Okay, I have a little bit more to say about that in a second. Okay, so I've mentioned I've mentioned trust. I'll go through this very quickly. I know we're running out of time. I've mentioned trust here in quite a few of those slides, and what I would argue is that for blockchain, you can think about many of these properties that it has. We think about resilience, think about immutability, and so on. But if you think of, technologies always have some kind of organizing principle that lead you to using it for a particular application. And in the case of blockchain, I would argue that the idea of trust is the organizing principle that you should think about first and foremost. It's not the only thing, but first and foremost, to decide, is this a good application of this particular technology? So here's a little bit of thinking around this. I'll go through this quickly. I'll be low on time. Okay, so here's a simple sort of dictionary definition of trust, right? One party is willing to rely on the action of another. I would argue that for most transactions, we actually don't trust the other party, right? It feels like it, but really we don't, right? We have this kind of derived trust, if you like. And I'm talking about typical transactions we make in stores and economic kind of financial transactions and so on. It's not that we trust in institutions, right? We're trusting the underlying laws and regulations, and then in turn the institutions underneath that, right? So these are the regulatory institutions, the enforcement institutions, and perhaps even the institutions that actually set the laws and so on in the first place. That's fundamentally where the trust is. And then going further, and I know this is possibly contentious, that I would argue that even for distributed systems, in the cryptocurrency space, that community that creates these, that community constitutes an institution of some kind, right? It is a collective of people with a common purpose that cooperate towards some kind of goal, right? So it is essentially an institution, and it has to be trusted, right? For anyone who wants to use Bitcoin and any other cryptocurrency, unless they're deeply expert, is not going to go and check the code, right? It's not going to go and check the code behind the wallet and so on, right? We trust others to do that typically, right? So this trust is required. All right. So I'm thinking a little bit about the landscape of trust. We trust some people more than others. We trust some institutions more than others, and so on. So there's kind of a bit of a spectrum of trust. And just to put a few waypoints on this spectrum, to just maybe add a little bit of color to thinking about trust. At one end of the spectrum, we have highly trusted relationships. Now, typically, these are between people. We have interpersonal relationships and so on. In many ways, these are the best, right? Because what it means is that we don't have to build controls in place to make sure people are behaving and so on, right? And that reduces this sort of complexity and allows us to engage in more complex enterprises that allow us to do greater things, right? Without having to constantly build these mechanisms and to guard against one another and create these inefficiencies. At the other end of the spectrum, of course, we have completely untrusted, and some of these are quite terrible, right? Because we have relationships between people that they don't trust one another, nevertheless, perhaps under duress or something, or they have no choice. They have to nevertheless enter into transactions for whatever reason, or transactions don't happen, right? They're foregone because there is no trust relationship. Between those two spectrums, there's a couple of points we can think about. So many transactions are mediated by a third party. Two parties that don't trust one another find a broker. A central bank fits into this category, I would argue, as a settlement agent. And then we have these transactions that are a bit of a blurred line here between the last two, but that is socially supported. In other words, we undertake transactions because there are there are a set of laws and regulations and so on that give us confidence that we can undertake these transactions. Okay. So the question is, well, there's this new kid on the block, I guess, a blockchain, which is different, not entirely new. You can argue that crowd mediation has happened before, but at a smaller scale. So, for example, on the island of Yap, I think it is, the Yap stone, this literally a large stone, is kind of seen by the community as a whole as representing value and owned by a particular party, right? And then when it changes hands, the community as a whole, that stone doesn't move to the house of the new owner. The community as a whole agrees that this stone is owned by someone else. But of course, DLT can help to do this at scale. This idea of mediating with a crowd. So we think about what can happen if we take each of these kinds of transactions and try and apply DLT. Well, in the case of untrusted transactions, perhaps now these transactions that were foregone can now happen, right? So that creates new activity. For third-party transactions, perhaps it lowers the cost, right? Because there's some kind of competition for these third parties through crowd mediation. For socially supported, maybe there are greater efficiencies that can be brought about by using DLT. And for the last one, I would argue that this is probably a bad idea. That I think applying a DLT really adds nothing here, because it's almost adds a friction where there's no friction in the first instance. Okay. Last a couple of points. No, we're low on time. Let me see. Well, I've touched on a couple of these things already, but let me just talk about the first one because we're low on time. I think the key thing here is that for those areas where there's no trusted third party, I think DLT really has some potential here, or where a third party can't be introduced. So we know there's lots of work going on in supply chains, for example, especially those that span jurisdictions where it's even harder to find a trusted third party. It's quite interesting, and OTC markets. Yeah, okay. In the interest of time, I'll just go to the next one. A couple of issues, and perhaps I'll just talk about the first one there, because I do wonder if the problem of governance of decentralized systems is one of the key things that's making it very hard to build systems with a blockchain. We have seen a few. We've seen lots of experiments. We've seen a few production systems. Most of those production systems feel very centralized to me. That they often tend to be run by a single entity. They're not truly decentralized. And I wonder if one of the reasons for that is that the governance problem is really hard. Just how do we govern, for example, the changes to these systems? How do we sort out that kind of balance between cooperation and competition between the parties involved and so on? And I think this is genuinely difficult where new work needs to be done. I think I should stop there. And if you want to read more, you can find more at the Bank of Canada website. There's quite a few papers we published over the years that you may find interesting. And I do apologize. I think I've run way over time. Andreas?
Dinesh, thank you so very much for this very, very comprehensive presentation today. It was touching not only the past, what you guys have been doing over there for the last 5 years, but it was also giving glimpses of where we may be heading moving forward. So in a regular room setting, there will be a long applause right now, but we're in a virtual setting, so there's not much we can do. I mean, I'm not gonna start clapping on my own, but again, thank you for this presentation. And now we're moving to the second part, which is the Q&A. Let me go and there's a chat channel for the audience to be typing their questions. The first question actually comes from Braden that says, why would all data not get replicated to all banks, but just be encrypted in a way that only valid parties can read the data? Then you only need recovery systems for the individual banks signing keys because they're already experts in storing credentials. The DLT infrastructure now becomes simpler and more robust.
Yeah, so I guess this is going back to the point about Corda, right? So Corda being architected in a way that makes sure that only the data pertinent to the parties involved in the transaction are stored on those nodes rather than being replicated everywhere. It's actually a good question because as sorry, I forgot the name of the questionnaire. You could argue that well, if you encrypt the data, why not just let it replicate everywhere encrypted? So one problem is I think foundationally this, to the extent to which you can trust a couple of things, right? So one is the storage of those keys, and then subsequently how much trust you can have in the crypto schemes. So over time, right? So you could imagine a future in which those crypto schemes could be compromised. Perhaps this could be many years. With the advent of quantum computing, for example, that could be one. And the other one is a simple one around just the efficacy of moving information around, storage requirements, where there's the efficiency of inefficiency of replicating state everywhere when you really don't need to, because there are costs there, especially when you think of transaction rates that are extremely high. So I think that would fundamentally be my answer there.
Yeah. Next question is, if you know, of course, by Matthew, what percentage of CBDCs, if you know, of course, are being piloted today on a blockchain DLT versus a centralized database?
Oh, well, I mean, we only have the one. From what I understand of the PBOC, I mean, the one in the Bahamas, which I believe is actually built on blockchain. As I understand it, and I don't know for sure, the one by the People's Bank of China is actually not DLT based. I think I remember actually a few years ago now, a article, I think in Bloomberg, where they were definitely interested in what DLT can bring to CBDC. But I believe one of the biggest problems, and it's easy to understand a market like China, is the throughput, the very limited throughput of DLT right now. We know that WeChat Pay, Alipay deal with huge transaction throughput, and I don't know what the aims are of CBDC, whether it's those types of rates, but I mean, let's be frank. At this point in time, blockchain is nowhere near being able to scale to that kind of that sort of level. More generally, I mean, what I will say is that there's lots of research being done, including by us, right? So we are actually thinking about DLT still, and I hope my presentation didn't make it seem as if we've completely decided that there are all these problems and so on, that then DLT is a non-starter for retail. We're still actively investigating it actually, because things are developing, right? There's still lots of development happening, lots of research, and there are definitely some qualities of DLT that are quite interesting. So I think, to answer the question, I think this is still active research, and I don't think maybe any central bank, apart from the Bahamas, have issued, has actually settled on the answer there. Still active research. It's quite early days actually in the world of CBDC, I think.
Okay, so thank you so much. So the next question is, forgive me, I'm trying to pipeline it. Okay, so Sermine is asking, too much trust in third parties is dangerous. Need to make the process simpler through a containerization approach. So what would be your comment to that?
Yeah, no, it's a good question actually, and that's one one thing on our mind. So
this question, Dinesh, how would you describe the containerization approach? What would be your definition?
Actually, I would have to ask the question exactly, but I have my interpretation about this, right? Which is that if there's a third party that's involved, some kind of intermediary, what containerization would force is a limited set of actions that intermediary can perform, right? So in other words, that they effectively can't do whatever they want, right? In other words, the central bank would provide some facility whereby there's a limited set of actions that the intermediary could perform, right? So limits their scope for actions. So, for example, an obvious example is the issuance of new CBDC or the minting of new money, right? An intermediary would not be able to do that to start with. So, but it's a really, I think I'll give one angle on this, why it's an interesting question, is if we think about a business model where we want to provide some kind of platform, for example, because we've mentioned we want to provide innovation where others can build value-added applications for end users and so on. If we have to have a lot of trust, chances are that means that we will have a very small set of intermediaries, because we need to probably, let's say police them or audit them very closely. But if we could provide something which is, to use those words, containerization, where we can provide a system where the number of the actions that these intermediaries can perform is actually very, very limited by design. Perhaps then we can really open things up, right? So now instead of having just say 5 intermediaries, maybe we can have dozens serving all sorts of markets. So I think it's actually quite an important question from the point of view of the scale of this and how much innovation we want to have.
Matthew, again, how do you think CBDCs will co-evolve or coexist with stable coins like USDC, Tether, and so forth?
Yeah.
Are those stable coins seen as threat? And the question over there, if I'm allowed to add a little bit, a stable coin, I mean, the Canadian dollar is stable against, the Canadian dollar, let's call it that way, right?
Mm.
Obviously there's floating exchanges and so forth, but there's a lot of things that back up the Canadian dollar. Now, USDC or Tether, they actually have backing of a currency or a basket of currencies. So there's this virtual country that exists that issues their own stable coin, and people are using it today. They're using it actually. Stable coins today, they occupy a very large percentage of the volume in crypto exchanges. So going back to the question is like how CBDCs compare to them or evolve with them, and are they seen as a threat?
So, I mean, to be honest with you, I don't think I'm well equipped to answer that question, actually. I should say, first of all, I'm not an economist, right? So, or a policymaker. But I'll give you kind of a personal view that's really not that well informed, right? Which is that I don't see why they wouldn't co-develop in the sense that I think they probably serve really quite different purposes, actually, right? So in other words, if a stable coin exists, I'm not quite sure if the value of the stable coin is really serving the same markets as a CBDC, both on the wholesale side and the retail side, right? It's difficult for me to see why there would actually be a huge overlap. But on the kind of wider question of is it a threat? I mean, I'm not quite sure what that means. If that means could it lead to financial instability because there's a whole shadow market there and so on. Honestly, I don't know. I'm just not well equipped to answer that question. I think that's for an economist, and I should probably leave it there.
Or possibly, as you said, a lawyer.
Yeah, quite possibly.
And actually, there was this discussion before we let the people in. Today, I was reading that in the United States, they're introducing 3 Democrats, I believe, they're introducing a bill about stable coins, right? So Matthew may or others may want to check about it. So Dennis, what problem is the central bank trying to solve with blockchain? Isn't it an oxymoron? Central bank and decentralized systems with a question mark. Is the main goal of CBDC the introduction of non-debt based money? Why not have just a simple database with logins? Otherwise, what happens when people lose private keys? Same private key.
Those are multiple questions. Sorry.
Pardon me?
Those are multiple questions. It's not one question. I just have multiple of them, so just one by one.
Okay. Okay, so let's go to the first part. So what the central bank is trying to solve with the blockchain, and isn't this an oxymoron? Central bank and decentralized systems.
Yeah, so it's funny actually. I had a slide earlier which you took out that actually used the word oxymoron in a very kind of similar way. So I mean, I should stress that the central bank is in no way committed to using a blockchain for anything, frankly, right? but it's a very good point, and I think that's one of the, I think the points I was trying to make, right, is that when you do have a trusted entity, a centralized entity, really, what is the point of having using a blockchain, right? Now, as I said, I think if that's the question, I think a lot of the reason for blockchain, if you have a trusted entity, meaning the central bank, actually goes away. But there may be some other kind of ancillary properties that blockchain has that could be useful. So I mentioned, for example, resilience, right? The fact that if you have a system where there are multiple operators and so on, and a fraction goes down, then we could still use it. So there's no commitment by any way. So I mean, when we think about CBDC, of course, this isn't this has nothing to do with blockchain, frankly. I mean, I think the second part of the question, why not just use a very simple centralized system? People just open an account, at the central bank, and that's it. You're done. So at one level, this is true. That's a CBDC, strictly speaking. It's a claim on the central bank. It's digital, right? And that's kind of it. But the trouble is, it's not quite as simple as that. In that, there's a set of these policy objectives we want to meet. So we've got to think about things like privacy. Well, if we do that, we just have a centralized account without anything else. Is that good enough for privacy? Right? For example, if the central bank can see all the transactions from everyone and so on, is that enough? So I think we probably need to go further than that. But absolutely, at one of the spectrum, that is absolutely a possibility. But it probably doesn't meet the policy goals in the way we're thinking about them.
The second part of the question says, is the main goal of CBDC the introduction of non-debt-based money?
I'm not quite sure what that means. I mean, it is yes, in the sense that
more credit-based money. Yeah, that's a bit.
Yeah, so it's actually exactly the same as a banknote, right? You should think of it exactly the same as a banknote, right? So in the case of a banknote, a banknote is issued against some collateral, right? So ultimately, a financial institution will park collateral at the central bank, treasury typically, and it's against that the central bank will issue a banknote. With CBDC, exactly the same mechanism, right? So there's no new. I don't know quite what the language is in economics. You have to forgive me, but effectively, this isn't a new monetary system, right? In terms of the fundamentals of what's going on, think about it like banknotes, right? There's nothing fundamentally new going on there.
Yeah. Apologies. So the last part of the question, I think we addressed it. Is like what happens when people lose private keys. We have more questions. We might want to jump on the next one by Mariam again. It's like, thank you for the great presentation. Is there a technical reason behind using the name DLT versus blockchain? Or does this mean that CBDCs are trying to distance themselves from the way the blockchain is used in Bitcoin, basically?
Oh, it's a nice question. No, I would say no. That's not the case. It's simply that, and there's area of confusion here. But I tend to think of a blockchain as a particular type of distributed ledger technology, right? So there's a particular class. So some people might say, for example, that Corda is not a blockchain as such. In fact, they themselves, I think, R3 describe it as blockchain inspired, I believe. But it's definitely a distributed ledger technology, but of a different kind, right? So this is more the kind of semantics of, I would think about categorization of these technologies. But no, there's no distancing. Yeah.
Okay, so Dennis asked a question that asked a clarification. Where can I send my long comments about the presentation? No replies on CB social media. So do you guys have somebody who Bank of Canada, I guess, has Twitter or stuff like that, right? Social media. Do you guys reply to those questions or?
No, it's a good question. Actually, I'm not completely sure. I don't think so. Yeah, the best thing to do is a couple of okay, two options, right? So just email me, right? And I don't have my email. I don't have my email, but anyway, it's a D Shah. So
Or I mean, if you want some comments, because I thought about it for a long time, and I can send it to you.
Dinesh, your
sorry, I didn't quite get that.
you can, if you want to give your email, there's a chat and you can type it over there.
Sure. Okay, I will do that. But anyway, dshaw@bankofcanada.ca. Okay, or find me on LinkedIn. Actually, maybe that's better. You can find me on LinkedIn pretty easily, and yeah, very happy to receive comments. Yeah, there's really no point sending them to some kind of general Bank of Canada thing, right? Just direct them to me. Yeah.
Okay, Tanya now asks and says the following: Thank you, Dinesh. How are indigenous and vulnerable groups been considering Canada's CBDC research and development? Are you guys talking to those groups directly?
That's a wonderful question, actually, because yeah, as I mentioned, universal access is one of our key policy objectives here. So, in fact, up to now, we've been fairly, just the nature of the research is we've been thinking about kind of fundamental policy drivers from the point of view of the bank. But I think now we're moving into the next phase where there's greater outreach. So from next year, you'll start seeing more and more of that, right? So we will be reaching out to Canadians in various forums, I think, in still being planned. It's exactly how we do that, but absolutely to make sure that we understand, what the needs are of Canadians, because of course we need to design this for particular needs, right? We need to find out, really where does this fit in more detail in the overall landscape of money and payments in Canada. And if I just heard correctly on the question, there are marginalized groups in Canada, right, that we need to serve. So we need to make sure that we're actually in touch with those folks, so we can design appropriately. It's going to be an important part of our work in 2021.
So the next one is not a question, but a comment by Lois. No, it was going to Chris, actually. So most likely it was replied in the chat. So apologies for that. And now we'll go to the nasty questions by the organizers. Starting with Henry, who has 3 of those. Henry, start picking bad habits for me. Can you speculate on the probability that we'll have a Canadian CBDC for retail in the next 5 years? Henry is new on asking nasty questions. I will make it even more nasty for you. You had a chart towards the end that said, here's the sufficient and necessary conditions. A, decline of use of physical cash, and / or a private party, and it can even be a private party, is like, it can be also another government, right? Issuing a currency. Actually, Daryl Duffy said something very interesting. I don't know if you follow that presentation. He said something very interesting in his comments. He said, if I was a small country like the Bahamas or like a very small country, I would be very worried about the CBDC of larger countries, right? Because all of a sudden, my currency is so small. It's not backed by billions or trillions of dollars or assets behind, right? So I would see, he said back in October, smaller countries issuing CBDCs faster than bigger countries. And as an example, you brought Bahamas into the conversation. So going back to the question, in my view, both of those conditions you gave are met. especially with the pandemic. I mean, I have $80 in my wallet. I don't know if I've used any of those in the past, how many months, I don't even remember. So Henry said, is like, would you envision Canadian CBDCs in the next 5 years? I would ask, when do you envision them? And especially in the fact that Facebook is going to have not a CBDC, but something very similar in the next few months. And PBOC is going to have something also very similar in the next few months.
So, well, I mean, and first of all, of course, Libra or DM is, of course, definitely not a CBDC. It will be a digital currency of sorts, right? So I mean, head on, I won't speculate, and it's not because I'm trying to dodge the question, because I genuinely don't know. I genuinely don't know, right? Because here's the thing, right? So you mentioned these two conditions, and it's true that on both of these there's movement, right? So it's pretty easy to see, just own everyday experience, that the use of cash has declined, right? But we still don't know if that's persistent, right? Or if that's permanent. So we don't know how much of a bounce back there is. And also, we don't know, because we haven't precisely said, because it's a difficult thing to say. Well, what exactly is the level? What exactly is the level of cash usage? At which point we think, okay, now it's time to introduce a CBDC. And similarly, you're quite right that the second scenario, and I shouldn't call it a condition, a scenario, with the advent of digital currencies, from DM and maybe others, could mean that there's some start of the use of non-Canadian dollar denominated currencies being used, but what that path is and the extent of it, we really don't know. So, and partly because we don't know, we're trying to be ready. We're trying to be in some state of readiness, right? So that, because this is a multi-year project, right? If we get to a position where we find out that actually, what, this kind of makes sense for us to introduce a CBDC, and we start from scratch, we're too late, right, for that. So at least we're doing the work to make sure that we have some state of readiness. We don't know exactly what that readiness is. It's not going to be, when if policymakers and the political side of the house says we should go ahead, we turn in the key and that's it, right? There's going to be some lead time, but we need to be ready to be in a position that.
But those things are now those things. I mean, I know quite a bit of what Facebook has been doing, and actually, to our kind audience, we're gonna have 2 back-to-back talks of Facebook in January and February as the next 2 installments of our blockchain series. But Carlos also, in a later question, asks something peripheral but very relevant to the question that we're exploring right now. He says, what will happen if a number of Canadians start to use another jurisdiction retail CBDC, like the DCEP? And actually, to a good extent, it's happening. If you go to Spadina, where Chinatown is, you can pay with WeChat, and we don't know if Canada benefits from taxes, if there's any taxation. And the difference between WeChat and DCEP is very so, and I would assume that projects of this magnitude, they don't happen overnight, right? Don't say, hey, let's release the CBDC next Monday and today is Thursday, right? Or are you actively working, and there can be an expedited, if I can ask, if of course you can disclose?
Well, I mean, we're working on it. I don't know if I do the word expedite. I mean, we're being careful because, I mean, the perspective here is that we have to be quite careful, right? Because, if we do build something, it has to be something that stands for decades, right? So we need, solid foundations on which to build, because of course there's a danger that if you rush something out, as per one of the previous questions, why not just have a centralized system where you just have accounts for everyone and be done with it? The problem with that is that it won't last very long, possibly, right? Won't last very long. In that it's very hard to build on top of that, right? Thinking about kind of value-added functions, thinking about how the world will evolve over the next 10 years. We have to fit the foundations of what we're building to the world as it will be in the future. So we do need time to think about, and it's true that there's a balance between how long it takes, because you can't take forever, of course, but also getting it right, and that's quite a tricky balance, right? And as I say, that there's no kind of timelines I can give you for that, except to say that it's a very active area of work, and right now we're thinking about the foundations.
Yeah. So the second question, because we're running, we don't want to cross the 2-hour mark. He says, Henry says, how would you roll out the infrastructure? Are you piggybacking on the existing systems? And then he says also a third question, if it is programmable, do you have to denominate the token, give it the dollar value when minted? But I guess Henry over here is like mining all those months that he's at home. So I don't think we're gonna be minting any CBDCs, right?
Well, so let me add something here. Sorry. The reason I asked that is because the digital dollar project in the U.S. is talking about the what's happened with the payments going to the unemployed folks, and how it would be much more efficient if they had a digital currency. But the issue with that is that if they do that, then that's actually monetary policy meeting fiscal policy, right? Because that's actually what I was getting at, is you do actually have the flexibility for this digital currency to be a mechanism for fiscal policy, if you sort of think more abstractly. So that's actually what I was really getting at, is if someone would actually do something like that.
Yeah. I mean, I guess the way we think about this, because people have mentioned this, if we need to make stimulus payments, for example, right, to Canadians and so on. Well, the first thing I would say was that the US case and the Canadian case have been quite different. So in Canada we did have payments made, right, and it was remarkably efficient and no CBDC, right? So but I know in the case of the US, there were checks mailed out and so on, right? Very different systems. That said, but perhaps the way to and again maybe others, my colleagues could probably answer this better. But the way I understand this is that if a CBD system were to exist, there's no particular reason why the fiscal authorities couldn't use it. All right, but it wouldn't be in the first instance a kind of a monetary stimulus from the bank. It would be the fiscal authorities using CBDC as a payment channel to get very quickly and easily to Canadians, right? So in that sense, the bank as a policy institution wouldn't really be involved. It would just be that CBDC is this mechanism, right, that the government could use just as it does now, right, in creating. But it's true that it could provide a lot of efficiencies, especially if we think about folks like who don't have bank accounts, right? One of the things that that should happen, back to universal access, is that even if you don't have a bank account, you should be able to use CBDC, right? So it could be a way of reaching those folks more easily.
Okay, thank you.
Okay, a clarification. Lois Turlo, it was by accident. It was not hello Chris. It was most likely hello Dinesh. It's like Lois Turlo from you may be able to see it on the chat. The Global Risk Institute. He works there. My recent research was on the potential shift of the global trade and reserve currency away from the US dollar. I can send you the link if you want me, Dinesh. I can do it after this talk. And I checked the link, actually. It seems interesting to be a paper. I didn't read the paper, of course, those 5-10 minutes, but maybe he wants to definitely share it with you. Let's wrap it up, and this will be the last few questions that we have. How does blockchain deal with the privacy of transactions?
I guess the way we think of it is that it inherently, blockchain itself doesn't, right? So we have these the cryptographic mechanisms that effectively sit on top of blockchain, but these are quite distinct, right? So we things like zero knowledge proofs can be used outside the context of blockchain. So there's nothing inherently in blockchain that provides privacy, I would say. But it's true that a lot of the research around privacy seems to be centered around blockchain right now. But I think they're quite distinct, actually. I would say, and it's actually useful to separate them out, right? Because we don't want to be sucked into this notion that, well, if you want privacy because these mechanisms are built on blockchain, you really should use blockchain. I don't think that's the case.
Okay, Itamar is asking, what's the impact on hackers, fraudsters, and other world money launderers, like essentially AML CFT?
Well, let's put it this way.
We can spend an hour talking about it. But...
Yeah. I mean, just to say, that CBDC would have to comply, right? So as with any other payment system, we would have to be compliant with the regulations pertaining to AML, ATF, and so on. So my hope is that the impact is positive in the sense that we reduce those risks. Yeah, not much, I guess, more I can say on that, except that that the compliance with those is a given for CBDC.